Alright, algebra students, in this video we're going to cover piecewise functions. Now, piecewise functions are basically where you have two or more functions, but they each have their own domain. And so domains are, again, they're referring to the part on the x-axis where they're located. So for instance, on number 1, we've got two different functions. We've got x squared minus 1, but that's everything from the left of negative 2 on the x-axis. And then we've got 5x plus 3 everywhere from negative 2 and then on the right hand side of that because it's greater than, but then it's including that negative 2 on that one. Okay? So first off, we're going to evaluate these things. Okay, so we're going to start off, we're going to evaluate negative 5. You've got to determine where negative 5 falls into this piecewise function. On this one, it falls into the top one, the x squared minus 1, because negative 5 is less than negative 2. Okay, so you look at the domains that each thing has, and the x squared minus 1 has this where x is less than negative 2. Well, negative 5 is less than negative 2. So what you do is you plug in negative 5 for x in this function. Makes it negative 5 squared minus 1. Well, negative 5 squared is 25. Subtract 1, you get 24. So if you were to evaluate that at that particular domain, negative 5 at that particular domain, you're plugging it into the x squared minus 1, and you get negative 2. Okay, for part B, it says we're plugging it in for negative 2. Well, negative 2 falls into this less or greater than or equal to negative 2 because it's equal to that. So we're going to plug it into the x value for 5x plus 3. So it's 5 times negative 2, and then add 3. So negative 10 plus 3 is negative 7. So if we were to evaluate f of negative 2, we get a negative 7. And then, lastly, we get f of 7. Well, f of 7 also falls into this greater than or equal to negative 2. So it's 5 times 7. And we're plugging it in for the x on that bottom one, and then plus 3. That's 35 plus 3, which is 38. So hopefully you see kind of what you're looking at, because there's multiple functions going on. They each have their own domain, and so basically parts of the graph that you are dealing with on these. Okay. Now number 2, we've got 3 things. Okay. Basically, the top equation is less than negative 4, less than or equal to, sorry, negative 4. The middle equation is between negative 4 and a positive 1. And then that bottom equation is where it's greater than or equal to a positive 1. So for instance, on letter A, if you're looking to figure out where to plug in the 2, well, of these 3 situations, it would fall into this very bottom one because 2 is greater than 1. So you're going to plug it into the bottom one. So 2 and then times 2 to the third power and then add 9. Well, 2 to the third power is 8. So it's 2 times 8 and then plus 9. That's 16 plus 9, which is going to give us 25. So your answer would be 25. Okay, now we'll move on to the next one. It says g of negative 1. Okay, it doesn't tell us which one to plug it into. We've got to figure that out. Well, negative 1 would fall into this middle range because it is between negative 4 and a positive 1. So we're going to plug it into that one. So it's negative and then negative 1 because that was the x value minus 1. It's going to turn it into 1 minus 1, which gives us 0. Okay, sorry forgot to box this first one in. And then lastly, okay, let's figure out this last one. We've got g of negative 6. Well, negative 6 falls into this top situation because it is less than or equal to negative 4. So we're going to plug it into the top function. So 1/2 times negative 6 and then plus 3. 1/2 of negative 6 is negative 3 plus 3 gives us 0 again. Okay, and there you go. Okay, so evaluating them is not too bad, I hope, but you've got to figure out which one to plug it into, and that just depends on what number it is you're talking about, and you're looking at the domain that it gives to you. Okay, now graphing them can be kind of tricky, but if you take this and you think about where it is that you're trying to omit or whatever, then I thought hopefully that'll make sense. And let's see if I can graph this on using this program here. We're going to graph each, on number 3, there are 2 different functions, and we're going to graph each of them, okay? But then we're going to eliminate part of it, okay? And I think that's probably some of the easiest things to do. On the top one, it says we're going to graph basically f of x is equal to x. If it helps you to think about this as though it was y equals x, that might be helpful. So y equals x, we would start at the origin, and then we would go up 1 over 1. And we can also go down 1 over 1, so we're going to put a lot of dots right here. Now I'm going to really focus on these ones on the left-hand side. Okay, I could continue drawing them on the right-hand side as well because, you know, it really includes that part as well. But I'm focused on the left-hand side because I really am focused on where x is less than or equal to -3. So what you do is you go to where x is -3. That would be at this part on the x-axis. And down on this graph, there is going to be a solid dot, and then it's going to be everything to the left of that because it's less than or equal to -3. So your graph would look like this. And if you really wanted to, you could, and it would probably be advised for you to erase all of these other points that you drew on there. Okay, so your graph would really look like this. So I go to the -3 and it is less than or equal to, so it is to the left of that little hash mark that I put on there. Now the next part of the graph, it says -2x plus 1. So you would go and you're going to plot this one again like normal. We're going to go up 1 and put a dot, and it says -2x. So I'm going to go down 2 over 1, down 2 over 1. Oh, that's the wrong spot. Down 2 over 1, down 2 over 1, down 2 over 1. Then I'm going to go up 2 over 1, and I'm going to do that a little bit too because, actually, hold on, I'm going to leave that last one open. This part of the line, or this bottom function, is going to look like a straight line that basically has this movement, but it goes to this -3, or it starts at this -3 and it comes from that. So if we were to start at the -3, it's going to start right here where I'm going to put a circle. Okay, and it's everything to the right of that. So I'm going to fill that in with a solid line. Okay, now here's the thing. I'm going to leave that as a circle. And here's the reason why I'm going to leave it as a circle. If you look back at the original equation, it says x is greater than -3. So that means that it's not including, on this bottom function, it's not including -3. The -3 got included on the red one. So that's why I included a solid red dot over there on that bottom function. Okay, but up on the top one, it's not included. So I'm going to leave a circle right there. Okay, that's important. Okay, now if you were to scan from left to right and you were to look at all the values that go along through here, now you might get confused because there is this jump between functions. But if you scan from left to right, right there at that -3, because there is a solid dot right there, it is included on that red function. So the domain is all real numbers. Okay, so the domain is all real numbers. And actually, let's put this into set notation. Okay, so it looks something kind of like that. Now, the range. The range, if you scan from bottom to top, because that's what we typically do, there's a function all the way down at the bottom. And it stops. It stops up here at a positive, let's see, 1, 2, 3, 4, 5, 6, 7. It stops at a positive 7. But it does not include that 7 because we have an open circle. Okay? So we're going to put this into set notation. This is y such that y is less than, not equal to, a positive 7. and we're going to leave it about like that. Okay, and that would be perfect. Okay, if you just put the y is less than 7, I mean, that'd probably be okay. I'm just kind of showing you some set notation. We talked about this very briefly one day. I think when at the end of class one day, but we didn't go too far into it. All right, now let's move on to the last one, number 4, on this page anyway. We've got two different functions on this one too. So we've got negative 3x minus 7. So we're going to go over to our graph. We're going to go down 7, and we're going to put a dot. And then it's negative 3, so up 3 over 1. And if you look at our domain on this one, it says that's less than negative 1. So I'm going to keep drawing more dots on this left-hand side. And that'll help me to draw my graph. So if I were to draw this graph, it's less than negative 1. The thing I've got to be careful with is that this dot at negative 1, this dot at negative 1 really shouldn't be a dot. It should be an open circle, I think, because it's not included at that negative 1. And if I were to fill in the rest of this stuff, it'd look about like this, where it has a straight line and it goes to the left. Okay, so that one should look about like that, and I can erase this other dot as well. Okay, so we go to where it is at negative 1, and it's less than that, so I draw the line to the left of that dot. Okay, I don't worry about everything to the right of it. Now, if you think about the second function basically is y is equal to negative 5 at this negative 1. Okay, so where x is negative 1. So I'm going to come down, let me change colors again. So I'm going to come down to negative 5, and that would be right here. Remember, y equals negative 5 is a straight line that goes across the page this way. Okay, but I need a closed dot at this negative 1 where x is negative 1, and then it's everything to the left hand of that point. Okay, again, it's a closed dot at that negative 1 because it is where x is greater than or equal to negative 1. Okay, so those are our two functions. Top one's the red one, the bottom one is the blue one. Okay, if we look at our domain again, domain, if you scan from left to right, well, on the left hand side it's going to continue to keep going up and to the left. It looks like it skips, but actually because of that dot right there, it's going to keep on going, and it keeps on going to the far right. So our domain is, once again, all real numbers. Okay, our range, all right, now this time, check this out. You have kind of a jump in things. Okay, so here's how I want you to write this one. It is the set where y is containing y is equal to negative 5, but then we have a union. Okay, that was a negative 5, by the way. When we have a union where y is, in this red line, would be where it is greater than negative 4. And then we'll close that off. Okay, so once again, if I scan from bottom to top and I'm going in this direction, I hit a graph at negative 5, and then I have this jump right here where there is no graph. That green little shaded area that I tried to draw right there, there is no graph. So I can't just say that it goes from negative 5 up. It has that little jump right there, and it picks back up again where y is at negative 4. And then it goes from negative 4 up, not including the negative 4. Okay, hopefully that makes sense. Let's flip it over, see what we got. On the next page, it's really more of the same. You know what would be good is if you guys pause the video and practice doing some of these. Okay, that would really be good, and then you could check your answer with what I put down eventually. But I'll explain it as we go. So we get negative 5 halves x minus 1, which means we're going to go down 1, and we're going to put a dot. And then from there, it's down 5, and then left 2. But I'm really more concerned about where all the things on this x-axis to the left or less than 2. So I'm going to go of 5, 1, 2, 3, 4, 5, and left 2. And I'm more concerned about those. So I'm looking at these ones on the left-hand side. okay, of 2. Actually, this dot that I put on the right hand side, I'm sorry, that one is at 2. I thought it said -2, but this is the dot that I'm concerned of. So actually, come to think of it, I'm going to need to erase that one, and I'm going to have to fill it in with a circle, because that 2 does not have a line underneath it. Okay, so from that point over to the left, I am drawing a straight line up and to the left. Okay, so that would have been my graph. Again, I went to the +2, and it's an open circle because it's not including that, and it's everything to the left of it. All right, on the bottom equation, we go up 2, we put a dot, and then from there, it's up 1 over 1. And you can see how there's a little bit of overlap, but my function notation tells me that I'm not really worried about all of that stuff. I'm only worried from where it is at +2 and then greater than that. So I go to +2. Again, I need to erase that little dot and put a circle. And it's everything to the right of that. So I'm going to draw my line to the right-hand side. Okay? And I'm going to erase these other little dots. And there's my graph. Okay? That one is done. So if we move on to the domain and the range. The domain, if you scan from left to right, it would be everything, except I'm not including the number 2. I have 2 open circles. So here's the way I want you to write this one. It's x such that x does not include 2. It's all real numbers almost, except it doesn't include that one little 2. All right. Now the range hopefully is a little bit easier. It's the y such that y is greater than, not equal to, 1, 2, 3, 4, 5, 6, greater than -6. And then it's everything that is on top of that. Now, we have some doubling up. We have some doubling up where the blue line starts, because then there's basically 2 graphs going on right there. That doesn't matter. Okay? We're basically telling everybody that there is a graph everywhere on the upper part of -6. Okay? Now, let's move on to -6 again. Try these out and do these without me and see if you guys can get it right. All right? And then you can unpause the video and then see what you did. So it's basically y is equal to -1, okay, but less than or equal to -5. Y is equal to -1. You'd go down 1, and it'd be this line. Hang on a second. Let's see. I'm gonna put a dot right here, and I'm gonna go this way. I'm just gonna draw some more dots because I have a feeling if I tried to erase, maybe it wouldn't erase. So it's everything that kind of goes like this. I'll chance it. Okay. Now, but it's less than or equal to 5. So I need to go to where x is 5. 1, 2, 3, 4, 5. And it is a solid dot right there, which means I need to erase all of these other things. Hey, look at this. I figured this out. I can erase right there. And it's everything from -5 and then to the left of that. Okay? Now the next one. So that one was the top one. I'm sorry if the switching colors messed you up on that one. Okay? So in this one, it's -x minus 3. So I go down 3, and I put a dot. And then it is -x. So it's down 1 over 1, and it's also up 1 over 1. And I'm just going to fill in this direction first. And then I'm going to keep going in this direction a little bit more. Okay, so it's going to be something like that, and I could draw my line. But it is from -5, not including the -5, because there's no line underneath it. So there's going to be a circle there. And then it's going to go all the way to a +1, but again, not including that +1. That means I got to do a little bit of erasing right here. So I got to get rid of those. And there's a circle right here as well. And it's a line segment that connects those two things. Okay? And then the last one, that bottom one, was y equals 6. But it's everywhere that is greater than or equal to a +1. So I go up to 6. 1, 2, 3, 4, 5, 6. And it would be everywhere this direction. okay? But I'm only concerned, again, at positive 1. Now, in this case, there is a line underneath, so it's everywhere from that positive 1. I do need to erase just a little bit to shave off where I started right there. And that would be my perfect graph. Look at that. So the top one this time I did in blue. Okay, I did this one in blue. I did the second one in red. And then I did the third one in green. If you look at the domain, if you scan from left to right, because, and I'll try to do this in yellow, right here there might be some confusion. But there is a dot where there is a circle, so there is a graph. There's also this part right here that might be some confusion. There is a dot where there is a circle, okay, if you're scanning from left to right. So your domain is all real numbers. Okay? The next thing, for the range. Now the range, if you're thinking about this, now switch to black on this. If you're scanning from bottom to top, we have a clear starting point, which is right here at this black line. Okay? And it goes everywhere, so it'd be Y, where Y, and it goes all the way up until we get to right here at this black line. So basically, it goes from -4, and it stops at a +2. Okay, so it would be between -4 and 2, so we would write it like that. Okay, so -4 is less than y, but that's less than 2. And that gives us in between right here. All right, and then it picks up again. It picks up again when we get to that green line, which is at a +1, 2, 3, 4, 5, 6. It's at a +6, so it's union y is equal to 6. And then it doesn't go any further. So that's what that would look like. Okay, kind of crazy, right? Hopefully you listen to the explanation, because all my colors might make it kind of confusing too. But let's try another one. Okay, number 7 again. We're going to do this top one in red. So this one we're going to do in red. So it's y equals 2x basically. Okay, so we start at 0, and then it's up 2 over 1. We could also go down 2 over 1. And I'm going to focus more on going down 2 over 1, because it's where x is less than or equal to a -2. So we go to -2. -2 would be this dot right here, and it's everywhere less than that. So it's that part of the graph. It is included with the -2, so I'm going to have that be a solid dot. Okay, the next part, it says we're worried about the graph where it is between -2 and a +4. Well, if I put this in slope-intercept form, this middle equation that I'm going to do in blue, it'd be -x minus 1. So that means that I go down 1 and I put a dot, and then it's -x, so it's down 1 over 1. So it looks something kind of like this. And so the thing about this one, at the -2, there should be a circle, because it's not included. There's a circle right in there. And then I go to where it would be 4. I'm just going to keep making dots. Now at the 4 right here, it's also going to be an open circle. And then I connect those two circles and all the dots. And so that middle one would look about like that. I mean, I could continue on the line if I wanted to, and that would be the entire equation if that's what I did. But it's only looking for between -2 and a +4. Last but not least, we've got y is equal to -3, but from 4 and to the right. Okay, so -3 is down here, 1, 2, 3. So -3 looks about like this right here. So it would be something kind of like that. But it's everywhere from that 4. So, and at that 4, we do have a line underneath it. So at that 4, there'd be a solid dot, and we're to the right of that. I need to do a little bit of erasing, because I included these pieces over here. I don't need that, and then I don't need that little piece right there. So that's our completed graph right there. Okay, so it's at the -3, but only from a +4 and over. Okay, so our graph is done. If we look at our domain and we scan it from left to right, well, that red line takes care of everything on the left, and then we have a circle but we have a dot right on top of us, so we're covered. Then we got the blue line as we travel to the right hand side, and then where there's a circle there's a dot, and the green picks up, and so this would be all real numbers. Once again, not always all real numbers, a lot of these happen to be. Alright, now if we scan from bottom to top, now down at the bottom the red one's got most of this stuff. But we do have a clear stopping point because I don't have a graph up at the very top of the page. So it's Y, where Y is, and if you look, like if you're scanning from bottom to top, well, that red one stops. The blue one and the green one, just barely the green one, but the blue one takes over for a little bit. And then the blue one finally stops at a positive 1. So it is where Y is less than a positive 1, and that is it. Okay? So there is a graph everywhere from positive 1 and down. Okay? Last one on this page. We've got negative 3x. Alright, again, I'm going to try to go a little bit faster on this one. Negative 3x would be at the 0, and then it's down 3 over 1. But again, I'm more focused with the up 3 over 1. And so it would look like that, kind of. I'm starting at the 0, but it's not going to include the 0, so I'm going to make this a circle, and I'm going to erase this other dot. That makes it from this point on. Okay? Then, you get negative 1/2 x minus 1. So at minus 1, you're going right here. Okay? And then down 1 over 2. And down 1 over 2. Down 1 over 2. So something kind of like that. At the 0, there's a line underneath it. So I have a closed dot. That's good. I don't have to change that. And then I continue this in. I go all the way over to a 6. And then at the 6, it does not have the line underneath it. So I'm going to fix that so that it is a circle. And then it's that little line segment that goes in between. And then the last part of it, the last one I'll do in green, we go down 7 and we put a dot, and it is up 1 over 1. Okay, so it would look kind of like this. Okay, at the 6, there is no line underneath it, so I'm going to change this into a circle. And it is greater than that 6, so it goes to the right of that. And all this other stuff I need to get rid of as well. And that's our completed graph. Now, if we look at our domain from left to right, we have one all the way up until we get to this spot right in here where there are 2 circles. And so basically it is everything where x is not a positive 6. And then it keeps on going forever and ever and ever. So it's just not 6. Okay? For the y values, we have a clear starting point, and that would be at, let's see, 1, 2, 3, 4, negative 4. And then if we go up from there, we have this part where there's a dot, but there's a circle, and then it keeps on going forever and ever. So it's y, where y is greater than, not equal to, though, a negative 4. Okay, so basically there is a graph somewhere if you go bigger than negative 4. That's it. Okay. Now we got a little bit more to do, so we're going to flip it over to the next page and see what's up. Okay, so this is like a full-on lesson for your first video, but honestly, if you're planning on taking the B or C version stuff, I wouldn't worry about this greatest integer function stuff. I'm probably going to focus more on this for the A version people. It's just some extra stuff that you don't use a lot of from time to time. So, you know, if you're B or C, especially if you're C, I wouldn't worry about this page. There's only one thing on your homework, and you could just leave it blank, to be honest with you. But we'll get into it. The greatest integer function, it's written as like this: f of x is equal to, and then you use these kind of double brackets. It looks kind of like this. So that's what it looks like. And that symbol that we have, yeah, like that, it means the greatest integer less than or equal to x. Okay? So basically, we're talking about just integers. We're skipping all the decimals and stuff. Okay? We're skipping all of those. So we are rounding down to the nearest integer. Okay? Let's think about that. If f of x is just regular old the greatest integer of x, right? Then, and we're talking about f of 7. Well, if I plugged that in, 7 is an integer, so the output there would just be 7. Okay? There's no need to round down because we are at an integer. We're going to cut out all of the decimals and stuff. But that doesn't mean we're rounding. We never round up, basically, because we always round down. For 2.3, the next integer down would be 2. Okay? And at negative 4.8, if we round down, we're rounding down to negative 5. So you always round down on these. Okay? Now, if there is a function inside the brackets, the double brackets or whatever, then you do that function and then you find the nearest integer down from that if you need to. So for a, 9 minus 5 is 4. Well, 4 is an integer, so you're good with that. Okay? If you do 0.5 minus 5 would be negative 4.5. And if we round down, you'd get negative 5. Okay? And then for part C, if you had negative 8.1 and you subtract 5, you get a negative 13.1. But if we're rounding down, it'd be a negative 14. Again, the next lowest integer that you've got. Okay? Now, we're going to make a table to help us generate a pattern here. Okay? And then we're going to graph the function that we've got. I think if you make a pattern, then you'll see this really clearly. Okay? So first off, if I were to take just some random points or whatever, let's plug in 0 first. If I plug in a 0, the greatest integer down from that, you don't have to round down or anything, you're just going to be at 0, right? Okay, and it includes that point, so I'm going to put a dot right there at the 0. All right, let's talk about decimals for a second. If I did 0.25, if I plugged that in, the next integer down from that would still be 0. If I did 0.5, you're rounding down again, right? You're still going to be at 0. If I did 0.75, you're going to round down to that, and it's going to still be 0, right? You go all the way to 0.99999 and further if you want to, you're going to round down to 0 until you get to that number 1. Number 1, you're going to keep it at 1. So at 1, you're going to have another dot at 1. So, on those zeros, if you're graphing this, you would continue a line over, and it would be all the way up until you get to 1, but not including 1. Okay? You get it? And then from 1, and I'll skip the 0.25s. At 1, if I go to 1.5, the next one down from that would be 1. Right? And hopefully you see that at 1.99999, you round down from that, it's going to be 1. So the 1 is going to go all the way over to you get to 2, but not including 2. Okay, because at 2, your output's going to be 2. And at 3, your output's going to be 3. Okay, so you can kind of start seeing the pattern. It's going to be kind of like a step looking thing where it looks like this. And something kind of like that. And we can go the other direction too, because it works that way too. And that's the basic one. Now we're going to flip it on to the next page. On the next page, we've got the greatest integer thing, but then we're going to subtract 5 from it. Okay? So we're going to get to play around with some transformations here. Okay? So let's continue that, or something similar anyway. I don't think we need to do the 0.25 or whatever. But let's start with 0. 0, the greatest integer down from that is going to be 0 because we don't need to move it all. And then if we subtract 5, you get negative 5. All right? Let's try a decimal, 0.5. Okay? At 0.5, the greatest integer down from that would be 0. Subtract 5, still going to be at negative 5. Okay? So at 0, we're at negative 5. Okay? And it's going to continue that away until you get to a positive 1. At positive 1, the greatest integer down is 1 because we don't need to round down from that. It's not a decimal. Subtract 5 and you get negative 4. Okay? So we go from 0 over, and it would be at negative 5 until we get to a positive 1. And then at the positive 1, the output would be at negative 4. So hopefully you see the pattern already. At 1.5, greatest integer down from that would be 1. Subtract it and you get negative 4 again. So it looks about like this. Okay? We do that all the way until we get to 2. 2, all of them would be rounded down to negative, well, they'd be rounded down to 2, and then subtract 5 and you get negative 3. At 3, it'd be negative 2. And at 4, it'd be negative 1. So your graph would look something kind of like this, where at each integer it goes over until the next grid line basically, and then you pick it up from there. Okay. Now I think I skipped out on the domain and the range on the last ones, so it's good. I'm going to pick it up on this one anyway. So the domain, if you scan from left to right, there should always be a graph. So it's all going to be all real numbers. Okay. Now, if you scan from top to bottom or bottom to top or whatever, I forgot a dot. There should be a dot right there. If you scan from bottom to top, it's not going to be included everything. And if you try to do unions and that set notation with new unions and stuff, you're going to be including, you're going to be busy because you're going to be doing basically doing infinity number of unions because it keeps on going forever and ever. So you could just say that it's the set of all integers, not natural numbers, but integers. And the way you do that is like this double back to z. Okay, and it looks kind of like that. It's basically a z, kind of like the r has 2 backs or whatever, but it's a z that has 2 slanted lines. Okay? Now, let's do number 5. Number 5, similar concept. The problem is on this one anyway is that when we plug in a 0, 0 minus 1 is negative 1. So the greatest integer down from negative 1 is negative 1 times 2 gives you negative 2. So at 0 we go down 2, put a dot. Okay, so let's try a decimal on this one. 0.5. At 0.5, if we subtract 1, you get negative 0.5. And then, so if you have negative 0.5 and you round that down, you'd be at negative 1. Negative 1 times 2, negative 1 times 2 would be at negative 2. Okay? So we go 0.5, we go negative 2. So we're still on this little line that goes right there, right? So let's try at, and I didn't go any further than that because we don't know what's going on. Let's try it at 1. Okay, let's continue going up. If we tried at 1, 1 minus 1 is 0. The greatest integer from that down is going to be 0 still. 0 times 2 is 0. So at 1, it's going to be at 0. Over 1 at 0. So you see how it skips? It jumped a little bit further on this one, right? So let's keep on going. Let's go 1.5. 1.5 minus 1 is 0.5. Round that down is 0. 0 times 2 is 0. Okay? So again, we go all the way over until we just barely get to 2 because at 2, 2 minus 1 is 1. 1 times 2 gives me 2. And again, you go over 2 and you go up 2 and you jump. And hopefully you can see the pattern here. Go over 1, skip, up 2, dot, over 1, circle. And then we could have the same thing going on over here so that they have something kind of like that. Okay, again, at 3, you would be at 4. And then at 4, you would be at 6. Okay, you'd be at 6. All right, so now let's fill out the domain and the range. Again, domain is going to be this time all real numbers, because if we go from left to right, you're going to always have, even on the gaps, like where there's circles, you're going to have dots right above them. Okay? Now, here's the funky thing, and I don't really even know if this is the perfect way of putting this, but if you go from bottom to top, okay, and you look and you start thinking about these, again, you can't write every single union on there because there's going to be just a zillion of them. Okay, so it's y such that, and I'm just going to put, because it goes 0, 2, 4, and it's -2, -4, I'm going to put y is even, because that's true. Okay, so it's every y where y is even. I'm sure there are other ways to write that, but that's what I'm going to put because it's algebra 2. It's, you know, if somebody tells you later on in life that there's a better way of doing it, then go with them. All right, number 6. Last but not least. And again, we're going to plug in some values. Let's start with 0. If I plugged in a 0, 0 times a half is 0, and then add 4, the greatest integer down from that would be 4. So at 0, 4, we're going to put a dot. All right, let's do the same thing, but let's do it for 0.5. If you did 1/2 of 0.5, you'd get 0.25, or 1/4. And then if you add 4 to that, you get 4 1/4. Okay? If you round down, you're still going to be at 4. Okay? Let's try at 1. Okay? So if you take a half of 1, well, that's a half. And if you add 4 to that, well, that's going to be 4 1/2. And if you round down from that, you're still going to be at 4. Okay? So at 1, we're still over here at 4. So it keeps on going past that this time. So let's try this at 1.5. If you do 1/2 times 1.5, you get 3/4. If you add 4 to that, you'd get 4 3/4. And if you round down, you're still at 4. All right? But we're getting closer, anyway, to getting to a point where we don't have to round down. So we're still at that halfway mark. We're still at 4. If you tried at 2, half of 2 is 1. 1 plus 4 is 5, and then we won't have to round down. We're still at 5. So at 2, 2 is where we take our jump, and we jump up to 5. And so if you look here, hopefully you can go ahead and start filling in the pattern, because we go over 2 this time. Okay, and that's our pattern on this one. You can continue the table on too if you wanted to. At 3. That'd be 1.5. Add that round down, you'd still be at 5. And you wouldn't until you get to 4. Half of 4 is 2. You would need to round down because it'd be at 6. Okay, so hopefully you see that you're instead of just going over 1 or whatever, you're going over 2 this time before you take your jump. All right, now again, the domain. If you scan from left to right, there is always going to be a graph, always. So again, it's all real numbers. Okay, and on all of these that I can think of, these greatest integer problems, there's always going to be all real numbers for the domain. For the range, though, it just depends on how and when it jumps. Okay, on that last one we had it where it was even. On this one, it's going to be back to where it's just all integers. Okay, so it's all integers. That Z was not as pretty, but it's all integers that you've got there. All right. Now, this is your homework. If you look, 1 through 8 are just regular old things. And then on the next page, you do have one problem that's the greatest integer problem. I told you if you're not taking the A version tests, I don't mind if you skip on that one. It's not that big of a deal to me. But you'll get this in class to do. So hopefully it looks similar to what you've done on the homework. Let me know if you have any questions.